Okay, so this is 2019 January question number 1. This question is about alkanes with the molecular formula shown. Give the IUPAC name of give the IUPAC name of an alkane that could be A. So we have to tell the IUPAC name for this one. So what is supposed to be the IUPAC name for this one? They have given you the molecular formula, right?
Yeah.
So in A, we have 6 carbon atoms. So I'm supposed to say if I have 6 carbon atoms, um, it's going to be C6H12. C6H12 means that now we are thinking whether I'm supposed to draw straight chain structure, whether I'm supposed to draw cyclic structure, whether I'm supposed to draw any branched structure, So, because it has 12 hydrogen atoms, like the double of hydrogen, it means that this is CnH2n. It shows that this is an alkene. And I told you, if you remember, the general formula for alkene is equal to the general formula for cycloalkane. So we can also draw cyclic structure. We can also draw any alkene. We can also draw cyclic structure because for the cycloalkane, the general formula is also the same, that is CnH2n. And also for alkene, of course, this is the general formula, that is CnH2n. So I can say uh, cyclohexane, cyclohexane, okay? And then if you are not writing cyclohexane, then you are supposed to write any of the alkene. Whether you write branched structure, whether you write straight chain structure, but it should follow the formula that is CnH2n. This is of 1 mark. Then in 1.2, they are saying draw skeletal formulas of 2 branched chain isomers of B. Branched chain isomers of B. B is C6H14. Of course, this is CnH2n plus 2, which shows that this is an alkane. This is CnH2n plus 2, and they are saying we have to draw the 2 branched chain isomer. So I would draw first 1, 2, 3, 4, 5, and then 5, and then 1 branch. Skeletal formula they are saying, right? Okay, 1, 2, 3, 4, 5, and then this is the branch. And then this is the branch. So this is called 2-methyl pentane. This is called 2-methyl pentane. In another structure, I would say this is going to be 3-methyl pentane. These are the 2 branched isomer. Type of isomerism. Type of isomerism where the molecular formula is same, but the position of branch is different. But functional group is same, of course. So I would say this is called chain isomer. This is chain isomer. And in fact, chain isomer is a type of structural isomer. So I would say this is structural isomerism. Structural isomerism. Then in
Okay.
1.3, thermal cracking of one molecule of C can form one molecule of B and 2 molecules of another organic compound. The reaction occurs at a high temperature. Write an equation for this reaction. State one other reaction condition needed. So they are saying one molecule of C. C is C22H46. When I'm going to crack it, C22 H46, they are saying it forms one molecule of B. They are saying one molecule of B, the molecular formula for B is C6H14, C6H14 plus and another molecule. They are saying and two molecules of another organic compound. So I'm going to subtract 6 carbon atoms from 22. I would be getting 16 carbon atoms, right? I would be getting 16, but I would
Hmm.
write 8. You know why? Because I have to I have to write two molecules. So 2 into 8 is 16. And how many hydrogens are left? H. I'm going to subtract 14 from 46. I would be getting 14 from 46. I would be getting 32. But I would not write 32. I would write 16. So now you have to check whether the equation is balanced or not. So 22. So 8 to the 16 plus 6 is 22. Hydrogens 14 plus 32. It's 46. So yes, the equation is balanced. And what
Wait,
are the conditions?
the number of hydrogens is in balance.
Number of hydrogens are not balanced. No, no, they are
Like
balanced.
we have like 30 oxygens on the right hand side and like hydrogens on the right hand side, and on the left hand side how many do we have?
This is
46.
46 hydrogens.
Yeah.
And then I have 14 plus 32. It's 46.
32 carbon. Oh, okay, okay, okay. Right. Okay.
And then reaction
Yeah,
condition.
yeah, it makes sense. It makes sense. Okay. Got it.
Yeah.
But that
So
was 22.
reaction condition we have to write. This is they are saying high temperature. So other condition, of course, pressure. So the pressure should be 10 atmosphere. The pressure should be 10 atmosphere, greater than 10 atmospheric pressure.
Okay.
Because when you are going to crack any molecule, high temperature and high pressure is needed. Under different conditions, catalytic cracking of C can occur as shown. Name the catalyst used. So zeolite. Zeolite is the catalyst which is used in catalytic cracking. Zeolite. D reacts with bromine gas. This is your D. This is your D, that is C3H8. This is an alkane, of course, CnH2n plus 2. It's not an alkene. D reacts with bromine gas in UV light or bright sunlight in the same way as methane reacts. The reaction is a free radical substitution reaction. Write an equation for the initiation step of this reaction. What do we do in initiation step? Formation of radical. How can we form a radical? Bromine molecule, when sunlight strikes, so then the two radicals of bromines are formed. This is called initiation step. Then they are saying write an equation to show the formation of a hydrocarbon in a termination step for the reaction of D with bromine gas in the UV light. To show the formation of a hydrocarbon in a terminate, what do we do in termination step? We have to eliminate the radical. We have to eliminate the radical in a termination step. And how can we eliminate the radical? The radical reacts with a radical. The radical reacts with a radical. So when they will be reacting with each other, when they will be reacting with each other, so unpaired electrons will be paired. So radicals are eliminated. So that is known as uh, termination step. That is known as termination step. So how can I write down the equation for the termination step? So I would say what's the molecule C3H8, right? So C3H7 is the radical will react with the same radical And when they will be reacting together, they will be forming a molecule that is a hydrocarbon. It would be 14. So that's the equation for the termination. We have different equations in termination. We can also write this equation. We can also write this equation, but in the question, what's the requirement? They are saying formation of a hydrocarbon. This is not hydrocarbon. This is halogenoalkane. This is not a hydrocarbon. This is not a halogenoalkane, right? So that's why I have written
Okay.
this equation.
Sir, I don't get in 1.6 what you did. Like you just formed a C6H14. Like, can you explain like 1.6 again? What you did in 1.6? The termination step.
Sorry?
Can you explain what you did in the termination step?
In a termination step, we are supposed to eliminate the radical.
Okay.
So in elimination, we have to terminate a radical. So how can we terminate a radical? Radicals have unpaired electron. Radicals have unpaired electron when they will be reacting with each other. So unpaired electrons will be getting paired. In this way, radicals are eliminated. So that's called termination step. You can take any of the radical which is formed in a chemical equation. Because if you remember when we were doing propagation step, in a propagation step, different radicals were formed. Some first CH3 radical were formed, then CH2Cl2 radical were formed, then CHCl2 radical were formed. So the basic concept for a termination is that to eliminate the radical. So how can we eliminate the radical? We can react any two radicals to eliminate unpaired electrons. And when you will be eliminating unpaired electrons, so it means that this is called termination step. But in this question, they have given us a reactant that is C3H8. So where it comes from? See this. I have reacted C3H8 with bromine radical. When it is reacted with C3H8, so C3H7Br, no, HBr is formed, and this is the radical. So I have taken these two radicals, they have reacted together. Electrons are eliminated, like unpaired electrons are getting paired. In this way, you have eliminated the radical. So this is called termination step.
All right. Okay. So two equations, right?
Com- yeah, no two equations, only one equation.
No, then wait. What
I'm
about the
saying
second
where it
equation?
comes from. I was explaining where it is coming
Oh,
from,
okay.
so I told you this equation. Okay,
And then why did you write two of those again?
because I have to eliminate the radical. So electron should react with electron. This is an it needs one
Oh, okay, I
electron.
got
It
it.
needs one electron. They will be reacting with each other. They will be forming this one. This is a hydrocarbon.
Okay.
Then in question two, they are saying compound E contains carbon, hydrogen, and oxygen only. E contains 54.51% carbon and 9.15% hydrogen by mass. Calculate the empirical formula of E.
So I think you take the percentages and, get the percentage of oxygen,
Okay, this is
by
carbon, this is hydrogen, this is oxygen. Percentage of
yep.
carbon is 54.51. Percentage of hydrogen is 9.1 and percentage of oxygen is 100 minus sum of 54.51 plus 9.15 divided by atomic mass of carbon divided by atomic mass of hydrogen divided by atomic mass of oxygen, that is 16. Or what's the answer?
Then you find out the ratios, and then you divide by the simplest ratio, and then you get your answer.
Yes. So this is what's the answer for this?
Yeah. One second. 4.54. 4.54.
And for oxygen,
Yeah. 1 second.
2.27
2.27. Yep.
divided by the smallest value, that is 2.27.
Divide all of them by 2.27, which would be the first one would be 2.
This is 4 and this is 1.
2,
So the formula
4, 1. Yeah.
is
C2H4.
C2H4O. And they are saying
Yep.
the mass spectrum of E showed a molecular ion peak with mass to charge 88. That's the molecular form. That's the molecular mass. Molecular ion peak tells us the molecular mass of a compound. Use this information and your answer to question 2.1 to determine the molecular formula of E. So
So you'll find out the
N is
empirical
equal
formula
to
is you'll find out
88
the
upon
empirical
empirical. Yeah. What's the empirical formula mass for this?
it's okay. 1 second. 12 plus 12 times 2 basically plus 16 times no, not 16. Yeah, plus 16 plus 4. So 44. So it would just be
88 upon 44 is equal to 22. And
22.
then
No, just 2,
C2
right? Yeah. Done.
will give us C4H8O2.
Yep.
Okay, the infrared spectrum of E shows a broad absorption in the region 3,000 to 35,000, 3,550. No absorption in the region 1680 to 1750, which shows that there is no carbonyl peak. Use table A in the data sheet to deduce what information the infrared spectrum provides about the structure of E. E, we got the molecular formula for E, that is C4H8O2. There are two oxygen atoms in it. There are two oxygen atoms in it. So, first of all, I am supposed to write, uh, the peak, like no absorption at this shows shows that there is no any carbonyl peak. Or, and what is this broad peak shows? 3230 to 3550. So I remember this was the peak of alcohol. Yes. So a broad absorption shows the presence of OH group. Outline a chemical test that would confirm that E contains a carbon-carbon double bond. This is very easy, of course. I would add bromine and then bromine will decolorize. If there would be carbon-carbon double bond.
Yeah, all right. Yeah, this is not that hard. Um, I'll just draw the primary alcohol to be like one where the carbon like is only attached with I think like one carbon, whereas like with the tertiary one there would be like one carbon would be
This
surrounding
one?
like all of the. Yeah, it would be like that.
Okay. And for the tertiary alcohol?
Like the middle carbon, yeah, it would be surrounded by three or like four carbons. Three, I think so. Yeah, like that.
Okay.
It's never like is there like instead of the OH, could there be like in some instance like CH3 as well or something?
This is the only way to draw tertiary alcohol, where we have three
Oh,
alkyl groups. One, two, and three. Describe how a
right.
student could distinguish between secondary alcohol and a tertiary alcohol. You know, secondary alcohol can be oxidized easily. After oxidation, it would form a ketone, but tertiary alcohol cannot be oxidized. So I am supposed
Okay.
to write down the reagent. So I would write oxidizing agent, that is
What about the tolerance
gas.
or the?
Tollens reagent is used to differentiate between aldehyde and ketone.
Oh, okay, okay,
Okay, aldehyde and ketone. Yes, I would write acidified K2CR2O7. So second for the secondary alcohol, orange to green because it can be oxidized. But for this, no visible change. So we must know which alcohol can be oxidized and which is not. A primary alcohol is partially oxidized to form compound F. Identify the functional group in F. Outline a chemical test that would be used to confirm the presence of this functional group. Of course, when we have a primary alcohol, it can be oxidized into aldehyde first, and aldehyde can be oxidized into carboxylic acid then. So functional group in F would be aldehyde, right? This is an aldehyde, and I would write the tolerance. I would add a tolerance reagent into it,
hmm, okay,
and then observation silver mirror formed.
right. And if there's no silver mirror, what does
Right,
it
and
mean? Like it's a ketone?
because no,
No, it's a ketone
silver
then?
mirror
No.
tolerance tolerance reagent only reacts with aldehyde. When it would be reacting with aldehyde, it would form product. So the observation of the product is silver mirror is obtained. When you see silver mirror, when you see silver mirror, so it means that this shows that there is an aldehyde. That's an observation basically.
Okay.
Write an equation to show the complete oxidation of 2-methyl propane 1-ol. 1-ol means this is a primary alcohol. And in
Mm.
your equation, write a displayed formula and use this one for to represent oxidizing agent. So displayed formula for 2-methyl propane 1-ol. First of all, I would write propane. This is 2-methyl. Oh, this is
It's on the
H
first one.
and this is OH. I'm going to oxidize it. And as a result of this, what would be the product? It's a primary alcohol.
So why do
There
you
would
have two ox? Okay.
because this is a primary alcohol, and primary alcohol means what would be the product if I would be oxidizing it? Yes, what would be the product?
Um, if you're oxidizing it, then there would be like the carboxylic acid, like
Yeah,
COOH.
exactly. And two, yeah, water molecule is released.
Ah, okay.
Yeah, this is an
So
equation for the oxidation. It's a full oxidation. When they will be saying you have to do partial oxidation, so I would be writing aldehyde.
okay. Also,
Many
sir,
fuels,
one more
yeah.
thing.
Hmm.
Whenever you have like a nitride, yeah, what would you do then? Like, what would the name of an something would of like nitride be?
Ethane
Something
nitrile,
that
propane nitrile, butane nitrile, pentane nitrile, like this.
that okay, okay.
Okay, question number 4 says many fuels belong to the homologous series of alkanes. Compounds in a homologous series give two other characteristics of a homologous series. They have told you the general formula is same. So I would say chemical properties are same, but the physical properties are different, isn't it? Physical
Yeah.
properties are different. Different physical properties. Different physical properties and same chemical properties. Write an equation to show the incomplete combustion of the alkane pentane forming carbon monoxide and water only. Incomplete combustion, right? So if I have pentane, molecular formula for pentane is C5H12. I'm going to combust it, reaction with oxygen. It would be forming carbon monoxide and water. I have to balance it. So 5 and then 6. And to balance oxygen, 6 ones are 6, 5 ones are 5, 5 plus 6 is 11. So I'm supposed to write 11 by 2. This is your balanced equation.
Okay.
Catalytic converters are used to remove NO and CO formed in petrol engines. Write an equation to show the reaction that occurs in a catalytic converter to remove these. Basically, NO will react with CO in the presence of rhodium catalyst that is present in a catalytic converter. CO will convert into CO2 and NO will convert into N2. How can I balance it? 2 moles of NO. So 2 moles of C. Yeah, this is balanced. Uh, when fossil fuels are burned in power stations, sulfur dioxide is formed. Give one reason why sulfur dioxide is removed. Identify a compound that could be used to remove sulfur dioxide. State the type of reaction that occurs when sulfur dioxide is removed. Sulfur dioxide. First of all, we have to know, is this acidic or basic? Is this acidic or basic? This is acidic. Why? This is a non-metal oxide. Why? This is a non-metal oxide. And non-metals oxide are acidic in nature. So I'm supposed to remove it by the addition of any base. That is lime, of course, CaO, or a limestone, that is calcium carbonate. Both are bases. And of course, when acid will react with base, so the type of reaction would be neutralization. So reason it's toxic. It shouldn't be in the air. It's toxic gas. And which compound should I add? Calcium carbonate. What's the type of reaction? Neutralization. What's the type of reaction? It's neutralization.
Okay.
See this question.
Yeah. Name and outline the mechanism to form T-bromobutane.
The alkene but-1-ene reacts with HBr to form a mixture of 1-bromobutane and 2-bromobutane. Name and outline the mechanism to form 2-bromobutane in this reaction. Of course, this is an alkene. So it would be electrophilic addition.
Okay.
And what's the mechanism? Just draw it and then send me fast.
Okay. Sir, can you again remind me that the double bond is the one that attacks on the HBr, right?
Yes. Curly arrows, lone
Yeah,
pairs,
that's correct. Yeah.
partial charges. And this is but 1-ene. This
Yeah.
is unsymmetrical alkene. So they have not mentioned, but they're saying to form a mixture of one bromobutane. Yeah, they have mentioned. So you have to write down the both products. Like, of course, one would be major product, another would be the minor product, of course. If this would be butene, that's going to be your symmetrical alkene, so only one product is formed.
All right.
Mm, no. Done?
Almost on the like drawing the last arrow. However, like I'm kind of confused about one thing, uh, which is that like I've drawn it properly for the I guess two bromobutane and the one bromobutane also I'll draw, but the confusion that I'm facing is that there are only going to be like three arrows, right? Only three.
Mm, yes.
Okay, then I should be correct. I'll send you a picture. Do I need to mention the major and the minor product?
No, no, they're only saying this is you have to draw the two bromobutane, not one.
Yeah. Just 1 second. All right, I'm sending you a picture. This should be correct. Sent it.
Okay, so this is again this is wrong.
What's wrong with
Still
it?
your mechanism is not good.
Is it
I
part
have bute one in. I have bute one in, that is
wait, I have the
CH2, CH3, and then this is CH, this is
bromine.
CH2, and it's
Wait,
reacting
it would
with,
be ER2 or something?
then this one, and
The arrows are
finally, and finally,
the
I have to write 2-butane, means that the bromine should attach on the second carbon atom. This is going to be positive, then CH2, then CH3, or then I have bromine having negative charge, having a lone pair of electron like this. It would attack on this one, and finally the product would be formed. That's it.
oh. Wait,
Okay,
sir, go up.
5.2. Okay, yes.
Other than the arrows that I got wrong, what else did I get wrong? Like the H. Can you draw in displayed formula the second part? Like after the arrow, can you draw that in a displayed form?
No,
Like how I've done.
no need to write down the product. This is the mechanism. But the thing is, you have
No, no, like was I
drawn
even
arrow.
half correct?
This arrow is correct. Your this arrow is correct, but this is wrong. Okay.
Wait, my arrow, that arrow wouldn't be correct because I showed it on the second carbon, right? You showed it on the first carbon.
Yeah, yeah. No, no, no. Okay, 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 okay. Wait. Yes, yes, you're right. You are right. Yes. I am supposed to write. I am supposed to
Two
write
bromo.
hydrogen on this and positive charge on it. Yes. Now this
Yeah,
is
yeah.
correct. Okay.
I
Your
didn't.
this arrow is
Yeah, so
correct and this is wrong. Okay.
only the first part is wrong, and the final product is also
Yeah.
correct. Then what I've done.
Yes. Yes.
Okay.
Okay.
And sir, in some cases, the arrow that I have drawn would be correct. Like in which case is that? Was that like the substitution one?
Nucleophilic substitution. Yes.
In that case, you're supposed to do like what I've done.
Nucleophilic substitution is something else. This is something else. You cannot compare it.
I know you cannot compare it, but I'm saying like in nucleophilic substitution, you're supposed to draw an arrow like how I've done in like the very first part, like an arrow straight from like the bond to the other bond, right? That I've done. Do you see that?
Yeah, kind of. You can say.
Uh,
Yes.
Wait, let me try to find a picture of nucleophilic.
Okay. Okay. 5.2, 15.96 gram of but1ene reacted to form a mixture of 1-bromobutane and 2-bromobutane. The mixture formed contains 6.88 gram of 1-bromobutane. Calculate the maximum amount in moles of 2-bromobutane that could be formed. That could be formed. So the first thing is that I have to find out the the grams of butanene. This is the grams of butanene, that is 15.96, and that is your reactant. So first of all, I have to find out the moles of butanene. 15.96 divided by the molecular mass of butanene. What's the molecular mass of butanene?
Um, Molecular mass
Butanene
of,
is C4H8.
yeah, so 12
C4,
times
12
4.
fours are 48. Yeah, it's 56.
Plus- Okay.
And the mole is 0.285, right?
Yep.
Okay. And then they're asking maximum amount in moles of 2-bromobutane that could be formed. That could be formed. So how can I find out the moles of 1-bromobutane?
Moles of
Since
one
I
bromo.
know the moles of since I know the moles of butanene, that is 0.258.
You also know of one bromobutane. They've given you
They
the.
have given the mass of 1-bromobutane, right? So
You have to
what can I
calculate
do?
the molar mass of it. One bromobutane.
What's the molar mass?
Bromine plus like butane. Butane we already found out. Bromine you can find out, which is I don't have it here. Second.
This is the structure for bromobutane.
Bromine, right? Wait. Bromine
Yes.
79.9.
Yeah. So it's going to
79.9.
be 136.9 as we
Right.
have 4 carbon atoms. So if you will be dividing it, you would be getting the moles, that is 0.0502 mole of 1-bromobutane. Or and then how can I find the moles of 2-bromobutane that could be formed?
Moles of 2 bromobutane.
Yeah,
Uh, wouldn't it be the same thing? Like,
you can see this.
what's the
2-bromobutane is equal to the reactant moles, the reactant one, and this one. So the remaining one would be the moles of 2-bromobutane, of course. So that is going to be 0.235 mole.
did you do?
This is more than this. This is more than this. Why? Because this is the major product. Major
No, no,
product
I
is
don't get what you
formed
did
in
here.
a higher quantity than minor product. Major product is formed in a higher quantity than a minor product. So that's why you can see the more number of moles of 2-bromobutane as compared to 1-bromobutane. So what I did, I have subtracted this one from the total moles, from the reactant, of course. So I would be getting
Why?
this one.
Because that's the one. You get like two products from butane,
Yeah.
as they said.
So I know
Okay.
the moles of one product. So I have subtracted it to get the other moles of product. Okay.
Right.
Yeah.
Okay.
And 5.3. In
Uh,
5.3, they are saying Y2-bromobutane is the major product.
I don't remember why. Because there's more of it being formed.
If you remember, I told you about the You can say which is more stable, which is less stable. We have a primary carbocation, we have a secondary carbocation, we have a tertiary carbocation. So we have to see in 2-bromobutane, of course, it's a secondary carbocation, which is more stable. That's why it's a major product. This is of 2 marks. So we are supposed to say uh, as 2-bromobutane is formed via secondary carbocation, which is more stable. Okay. Or
Uh,
give the reagent
which is
and
more stable.
conditions
Okay.
needed. Yeah, which is more stable than the primary carbocation, of course. Give the reagents and conditions needed for this reaction. G and H. Okay. So alcohol. So alcohol to alkene. Alcohol to alkene. What should be the reagent?
Alcohol to alkene. I think it should be a reducing agent. No, no, no,
Reducing agent.
no,
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 no.
no, 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 no. Um, what is it like the K? Is it the K thing? What was it?
It's a dehydration,
Phosphorus?
isn't it?
What?
It's a dehydration, isn't it? The removal of water molecule,
Acid,
right?
right? Reduce maybe something like.
So concentrated sulfuric acid should be used because concentrated sulfuric acid is a dehydrating agent. So I would say concentrated sulfuric acid. I would say concentrated sulfuric acid, which is dehydrating agent. And then condition is hot. Outline the mechanism for the dehydration of 2-butane 2-ol to produce H. H is alkene. It's butene.
Right.
It's butene from secondary alcohol. Yeah, we have secondary alcohol. That is this. Then OH. OH is this. It has a lone pair of electron. First of all, this lone pair of electron would be attacking on partial positive, no, positive hydrogen atom. And then as a result of this, this would be formed. As a result of this is going to form, and the charge on oxygen is positive. When oxygen has 3 bonds, oxygen becomes positive. This is unstable. This is unstable. I have to make it stable. How can I make it stable? So I can say that I can say that it would be taking electron of carbon. As a result of this, carbon would be getting positively charged like that. Carbon would be getting positive charge like that, and the water is removed. Now this is positive carbon atom. To make it more clear, I am drawing hydrogen like that. Hydrogen will give its electron to this, and the double bond is formed, and finally alkene would be formed. This is the mechanism. This is the mechanism. Else, if you remember, I told you this one as well. I told you this one as well. I'm going to draw it. Butene, that is, this is butanol, butane 2 all. So it has a positive charge, right?
Right.
So we can also draw like that. But you have to, this is mandatory to do. Here we have options. Once oxygen got a positive charge, so we can,
Hmm.
but
Yeah,
you
this is
have to
like a
do this.
different. This is somewhat of a different mechanism. It looks different compared to
We,
what we have done.
yeah, we have done elimination of chlorine, dehydrohalogenation. This is called dehydration. So that's why dehydration, this is also an elimination reaction. Why we are saying this is dehydration? Because it's more specific to the water molecules. That's why I'm saying it's a dehydration reaction. Whenever we have elimination reaction in which we are going to remove water molecule, so we have to do this elimination, like we have to do this mechanism like that. Water should get a positive charge because we have to eliminate it. Once water molecule will be getting a positive charge, it would be eliminated in an easier manner.
Okay.
Now see this? This is very easy.
Can you show me H again?
This is H.
All right. Here you can scroll back down.
Then isomer 1 and isomer 2.
Yeah. Let's do CDIs. I think in one of them we'd have the H on like one side and like the CH3 on like one side, and then for isomer two we can have like H on top and CH3 on the bottom. If that makes
Like
sense.
you're saying E and Z, right?
Yeah, yeah.
Okay.
That's what stereoisomer is, right?
First one is this.
One of them can be like that.
And
Yep.
another one is supposed to be
Both
in which
are supposed to be the same group.
I'm supposed to flip it. So the first one is it's E. It's E.
Wait, sir.
But
I thought of it a different way, but I don't know if I would be correct as well.
what's the condition to have cis trans isomer?
What is it? Condition? Not sure.
Number one, there should be a double bond. Number one, there should
Hmm.
be a double bond. Number two, different groups should be attached on the double bond. Then it would give you cis trans isomer.
Okay. But I have a question.
Hmm.
Like if you see the picture that I've just sent you,
Hmm.
um, are these both the same thing? What I've drawn? I mean, I haven't like what I'm trying to show you. Are they both the same thing?
CH3, no, 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 completely wrong. In the first structure, how is that possible? The carbon atom have a same groups attached. If there
Right.
is a same
Okay.
group attached, this trans isomer is not possible.
No, it's not even like Z or E or any of them.
It's nothing. Neither E
Okay.
nor
And
Z.
second one, even the second one's nothing, right?
So yeah, second one is right.
Right, as in for what? Which one?
This is Z.
What you have drawn.
Yeah.
Okay.
G undergoes addition polymerization. Draw a section of the polymer formed. Draw a section
Okay.
of polymer formed showing one repeat unit. Showing one repeat unit. So G is, where is G? G
I don't know.
undergoes, H exists as 2. Okay, this is 6.3. Okay, this is 6.2. Yeah, this is G. So I have to write down the polymerization product. In a polymerization, double bond is eliminated and we have a single bond. So carbon, single bond carbon, and this is the continuation line. This is two hydrogen and this is one hydrogen and this is C2H5. That's it. Because this is G. This is G. Two hydrogen atoms and this is one H and C2H5. Addition polymers are made from alkenes. Yes. State one advantage of using alcohols rather than crude oil as the source of alkene. As the source of alkene.
Okay.
Because addition polymers are formed from alkene. They are saying um, state one advantage of using alcohols rather than crude oil as the source of alkene, because we can also convert alcohol into alkene by dehydrating it, and we can also get alkene from the crude oil. So the advantage is that alcohols are made from sugars which are renewable, but crude oil is non-renewable. This is advantage. It's of only 1 mark. So I would say crude oil is non-renewable. This is the last question about epoxy ethane. Draw the displayed formula of epoxy ethane. Two carbon with one oxygen. So I would write two carbon with oxygen like that and four hydrogen atoms. Epoxy ethane is manufactured from ethene. Write an equation and identify the catalyst for this reaction. So equation epoxy ethane is manufactured. So I have to make epoxy ethane, that is C2H4O from ethene. Ethene is C2H4. It should react with oxygen. And how can I balance it? I'm supposed to write 2, then I'm supposed to write 2. This is balanced. Catalyst, silver. We use silver catalyst. We use silver catalyst when we prepare epoxy ethane. Identify the product when 1 mole of epoxy ethane reacts with 1 mole of water. 1 mole of water. Yes.
Um, 1 mole of epoxyethane with 1 mole of water. Does it? I mean, it gains an oxygen, I guess. Oxythane. So does that wait? What would it be?
It forms an
Ethane,
alcohol.
maybe.
It forms an
Does
alcohol.
it become into like a ethane? Ethane?
It would form ethane 1,2-diol.
Oh, wait. Can you show me in like the displayed formula, sir?
Okay.
How the reaction would be occurring?
This is epoxy ethane, like that. It's reacting with water. Okay. So that would be the product. Okay. Two hydrogens and one oxygen is attached. Two hydrogen and one oxygen is already there. One oxygen was already there. I have attached one more and two hydrogen atoms. That's it.
Okay. One second. Yeah, all right. Wait. So, oh, it's the right. Okay. Okay, makes sense. All right. Yeah, you can go to the next question.
Question 8. Halogenoalkanes react with hydroxide ions in two different ways. The hydroxide ion acts either as a nucleophile or as a base. Give the meaning of the term Give the meaning of the term nucleophile. Electron pair donor.
Yep. Okay.
The hydroxide ion acts as a nucleophile in the reaction. State the conditions needed for this reaction. When 2-bromopropane to form propane 2-ol. Bromine would be substituted by OH. So we need aqueous condition. 2-chloropropane also reacts with hydroxide ion to form uh, okay, is slower than the reaction of 2-bromopropane. Yeah. So why 2-chloropropane is slower and 2-bromopropane is faster? It depends on the size of bromine. When the size, like the bond length of bromine, as the size of bromine is larger, so the attraction between the carbon and bromine would be lower. So this bond can be broken down easily. So the reaction is faster. But the bond of carbon and chlorine is stronger. That's why more energy is needed to break down the bond. That's why the reaction is slower. It's of only 1 mark. So I would say um, bond of carbon and chlorine is stronger. then carbon and bromine. Okay. Hydroxide ions acts as a base in elimination reactions with halogenoalkanes. State the conditions needed for these reactions. Draw the structure of the organic product formed when 2-iodo 2-methyl propane reacts with hydroxide ions in an elimination reaction. Of course, the condition is alcoholic condition. Alcoholic condition and heat. Why I'm saying alcoholic condition? Because alkene is formed. This is an elimination reaction. If I would be doing nucleophilic substitution, I would be writing aqueous condition. Then structure of organic product 2-iodo 2-methyl propane. 2-iodo 2-iodo 2-methyl propane. When I would be eliminating it as a result of this, as a result of this, I would say that would be the product. Because HI is removed. We can also remove it from the right hand side as well, the same thing. This would be the product. Okay.
Okay.
Now see this. Calculate the amount in moles of CH3, CH2, COO, CH2, CH3 at equilibrium. Use your answer to calculate the amount of ethanol and of water in the equilibrium mixture. Okay. They have given us equation that is this CH3, CH2OH. This is an ester and this water. Initial amount they have given 2.45 moles of ethanol, 1.20 mole of propanoic acid, and 0.87 mole of water. The mixture was left to reach equilibrium. This is X, this is X, this is X, and this is X. Equilibrium mixture contained much grams of ester. Can you tell me the moles? 55.08 divided by 102. I'm going to find out the moles of an ester. They have given the MR as well.
Right. Um, Sir, in the initial amount, okay, no one. Um, what do you want me to do? Get the 55 point that part?
Moles.
Uh, 0.54.
So 0.54 moles of ester at equilibrium. And I have to calculate the moles of ethanol and water in the equilibrium.
Sorry. Sorry, what?
I have to calculate the moles of ethanol and water in the equilibrium. This is ethanol and this is water.
Yeah, so you're going to do 2.45.
0.87 plus x and
Yeah,
2.45 minus x. But I need
yep.
to know x. What is x?
You can find out x, right? Think it would be like 0.87 plus x is equals to something. Or no,
Yeah, it's
x is equals to
0.54.
0.4.
Yeah, so 2.45 minus 0.54 is equal to 1.91. Yeah. So this is 1.91 and 0.87 plus 0.54 is equal to 1.41. That's it.
Okay.
Okay, amount of ethanol is 1.91. Amount of
So
water is
also, sir,
0.
one before
Yeah.
the arrow, before like the arrow, yeah, before the equilibrium arrow, you're going to like whatever there is like with the IA and the AR, you always subtract them, right?
Yeah, I subtracted it. Yes.
Okay. All right.
State why Kc doesn't have units. Why Kc doesn't have units. If you can see your equation, equal number of moles, 1, 1, 1, 1. Since I know that Kc is equal to product upon reactant, this is an ester, this is water,
All right.
this is ethanol, this is ethanoic acid, propanoic acid. So why Kc doesn't have any unit? Equal number of moles of reactants. Okay, one more. Calculate a value for Kc for this equilibrium under these conditions. They have given you all the moles. I need to just put it in that equation. Ester is 0.033. Water is 0.567. Ethanol is ethanol is 0.033. And acid is 0.033. Yeah, the same thing. And ester is 0.067. Okay. Yes. Just we have to solve it. What's the answer for this?
One second. Answer is 34.9.
Okay.
Hello? Yeah, 34.9.
This is 34.9. Okay. For this equilibrium, predict the effect of an increase in temperature on the value of Kc. We have to see whether the reaction is exothermic or endothermic. So they are saying the reaction is exothermic. Delta H is negative. If you will increase the temperature of an exothermic reaction, so the Kc will decrease. And if that's going to be an endothermic, so the Kc will increase. That's it for this page.